Howdy. In this video, I'm going to continue explaining the logistic regression. In the first video, we looked from the predictive modeling part and discussed certain functions to get to the predictions. And our results were, we were almost 95% accurate in terms of classifying whether a person will get loan or not. Now, in this video, I'm going to discuss the modeling, logistic regression modeling from explanatory study, right? So all these functions I have just shown you in the earlier one, so I just put them together, eliminated the space. So we are introducing pandas or importing pandas, matplotlib, and scikit-learn model selection train test split. We read the data file from this folder, and I also reindexed the file as ID being my index. We defined this fixed experience function to basically change the negative experience to 0, right? Also, there was an education field, and in that education field, basically I had 1, 2, 3, and those were undergrad, graduate studies, and advanced studies. So I just created dummy variables for that one. And the next step, I renamed those dummy variables such that education 2 becomes graduate degree, education 3 becomes advanced degree, right? And finally, I dropped the bank data, the zip code column from the data set because I didn't know how to use it at this point. All right, so let's run this one and start for the rest of the analysis. First, I'm gonna just create a logit model using a single variable, and that would be the income. So I wanna know if a person's income increases, whether they will be willing to get a loan when we give them the offer. So first I'm going to import the StatsModel API as SM, right? Then I'm going to build this model in a couple of steps from the statistics, logit model perspective. First, I'm going to check the situation where we have only a single variable, independent variable, namely income, and see if that explains the model good. And then I will add the other variables and try to improve the situation even further by looking at different things. All right. So let me go say X income. So I'm just looking at the X variable and income, and I'm going to say that is equal to bank data income column, right? And if you guys remember, when we do the StatsModel regression analysis, it didn't actually have an intercept by default. So I'm going to add an constant to serve as the intercept for this model, right? So X is going to be SM add constant, right? I'm going to add that constant to X inc, right? So I added that one. Let me define my Y variables as well. And that is basically same way, bank data. And this time it is the personal loan field, right? All right, next I'm gonna call that train test split function to basically create a training data set and so forth. So let me start xtrain. I'm gonna call it number 1 because I'm using the only one variable income in this case, and I will keep creating more models. So just maintain that one. X validation 1, and then X Y train and Y validation. Now for Y train and Y validation, I don't have any changes because it's always gonna be the personal loan, but X train, basically I might add columns to the model, so that will change, and that's why I'm saying it is 1, 2, and so forth later, right? And I'm gonna say test Test train, hopefully it will pick up. It's not picking up, so that means I need to just keep writing it. Split, and then open parentheses. For x I'm gonna say x income, and for y it is y variable, right? And I need to define the training data size, data set size, and then finally a random state. All right, and that is, I'm gonna just use 2, right? It is train, test, and split, and that's why it wasn't coming up. All right, so that should explain it. All right, yeah, we'll take care of that one in the future. So now I have basically validation and training data set. Next, I'm gonna create my first model, logit, and I'm creating this one for income only, right? And I'm gonna just say SM, basically that's StatsModel, use the logit, and then for that I'm gonna call yTrain and then xTrain1, right? And while at it, I'll just say results, and let me just put the income as well, and that is going to be logit inc, and then I'm gonna fit it, so basically optimizing the parameters for this one, right? And finally I'm gonna print this results to check what is in it, inc, and then summary of that, right? All right, so here's the result. I have constant and income in the model. So this is the personal dependent variable. Model is logit. We are using maximum likelihood estimation to optimize the parameters. Data I ran and it's converged as an optimization. For the logit regression, there is not really a true R-square value, so they use a pseudo R-square calculation. When I look at the coefficients, constant has -6.227 and income is 0.0385. And when I check the p-values, both of them are very small, less than 0 in the, like close to 0 in this case. So that tells me that basically these two coefficients are significant. These z values are basically coefficients are divided by the standard error, right? And that's it. So it looks okay, but I'm gonna create another model. This time I'm going to use XWARS, all right? So I'm gonna include all the data columns except personal loan, of course, and that is going to be dropping. All right, so personal loan, and then I want to do it for axis 1, basically the column, right? And then I'm gonna go ahead and add the intercept because it doesn't have the intercept initially. And if I do just if I don't include, it's not gonna have the intercept. And I'm going to also just copy paste this one, all right, here, and this time call these 2, all right, and this is x variables, and this is still y where I defined earlier, right? Y was bank data personal loan. Okay, so let me get that one. It's okay. All right, so I'm gonna just go ahead and go through these similar calculations and look into it. So I'm gonna copy paste. So I will call this one logit model all, and I'm calling the logit model again. This time the training data is 2, not 1, and I'm gonna rename this one as all 2 and all. All right, let's check it out. It took again 8 iteration. This time pseudo r square is almost the same. Oh, I did something wrong. Not wrong, but missing. All right, so I need to adjust my model. So I was printing the older model. All right, so my pseudo r square value increased. All right, and then if I look into the values, it seems constant value decreased to from 6, around -6 to -13. If a person has a security account, it is less likely that they are going to get loan. If they have online account, similarly negative. Credit card, again, basically probably they are using their credit card rather than going to borrowing money, right? Then when I look into the p values, the constant is significant, but age and experience seems to be not impacting the model accuracy much, as well as this mortgage account. So so these 3 could be dropped from the model, and honestly I actually dropped them all like one by one to see at which point I would get the all the variable going into the model statistically significant, right? Now there is a note here, the possibly complete quasi separation, a fraction of 13% of it can be perfectly predicted. What it means is that there is one variable here or more. They are, by just looking at that variable, I can classify 13% of the observation correctly. For example, it might be income. I can just look into a person's income and decide if people are going to get the loan or not, right? I just making up. I could go investigate further, but at this point, we are gonna just stop, right? So as I mentioned, I actually went and dropped one by one to see if those numbers are changing, and when I drop one of them, the others become statistically significant, but they did not. So I'm gonna create my set of variable, and I will call this one reduced, right? This time what I'm going to do is from the x where's I'm gonna drop the following. Oops, not this. I'm going to drop age, comma, experience. Of course, if I could put these, that would make sense. And then I'm gonna age, experience, and drop mortgage, right? Right. And once I drop those, I'm gonna say do this on axis, right? And my y variables is still the same. And remember, at this point the constant is already there, so I don't need to do anything else, right? And I can look into x reduced, right? Let's see. Yeah, age, experience are dropped from the model, right? So I'm good. So the next step is going to be something similar. So I'm gonna create a new set of training data and validation data, and I will call this as 3, right? I got that one, and then I will actually just copy these lines as well and put it underneath. Right, I will call this one as reduced, right? Logit train 3, right? And reduced. This is reduced. And this is reduced, right? Right, it took 9 iteration. If I look into pseudo R-squared value, it is almost the same. Everything else at this point is statistically significant, right? So what I'm observing is that, again, if somebody has a security account, exchange account, they are less likely to basically use the loan. If they have credit card, it's less likely, but degree and advanced degree owners tends to get loan more frequently, or it adds them to get more frequently. Expenditure on credit card, the family size, and so forth are significant or impacts them to get more of this offer.